Imagine standing on Mars. The sky is a hazy butterscotch pink. The ground is a sea of red, stretching endlessly. You're a pioneer, prepared for the obvious dangers. Deadly cold. Cosmic radiation. You have a suit for the cold, a habitat for pressure, and shielding for radiation. But the deadliest thing on Mars isn't a dramatic explosion or a sudden loss of oxygen. It's the ground itself, the fine, reddish powder that coats everything. Martian dust? This isn't Earth's dust, it's Martian regolith. A silent, creeping killer. It grinds down machines and poses a toxic threat to your lungs. Every step kicks up a cloud, every breeze carries it. It clings to your suit, follows you inside, and resists every attempt to brush it off. The real challenge isn't just building strong shelters, it's fighting a microscopic war against dust. Mars wears you down, particle by particle. Your greatest adversary isn't what you see in movies, it's the dust. Waging a relentless war of attrition. On Mars, the smallest threat is the one most likely to bring a mission to a grinding halt. What is this Martian menace? Scientists call it regolith, a layer of loose, broken rock and dust. On Earth, water and wind smooth our dust. Life breaks it down. Our dust is soft, worn, and harmless. Martian dust is different, sharp, young, and angry. Mars lost its water eons ago. Its thin air can't smooth rocks. Instead, meteorites smash the surface into jagged shards. Earth dust is like sea glass. Martian dust is like microscopic, freshly broken glass, sharp and abrasive. This sharpness destroys machinery. Grinding seals, scratching solar panels, clogging moving parts. But the danger isn't just physical. Martian regolith is chemically hostile. Laced with perchlorates, compounds toxic to humans, known to disrupt thyroid function. The surface is bathed in UV radiation, creating a cocktail of reactive chemicals. The dust is also electrostatic. Clinging stubbornly to everything, spacesuits, rovers, instruments. You can't just brush it off. It's abrasive, toxic, and sticky, a triple threat. This makes Martian dust one of the biggest obstacles to sending humans to Mars. Every mission must contend with this perfect storm of hazards. Surviving Mars means surviving its dust. Ignore it and it will end your mission. The Opportunity rover is the perfect case study in Martian dust power. Designed for 90 days, it lasted nearly 15 years. Thanks to luck and engineering, dust slowly coated its solar panels, threatening to suffocate it. Occasionally, Martian winds would clear the panels, granting Opportunity a reprieve. But the dust always returned, grinding into joints, wheels, and gears. The rover's life was a constant battle against this fine-grained enemy. In 2018, a planet-wide dust storm blotted out the sun. Opportunity's batteries drained. The rover fell silent, never to awaken. NASA declared the mission over in 2019. The little rover that could was finally conquered by dust. Martian dust is relentless. It outlasts even our best machines. Every future mission must learn from Opportunity's struggle. On Mars, dust always wins in the end. The lesson: underestimate it, and you'll lose. For robots, Martian dust is a mechanical nightmare. For humans, it's a direct threat to life. The dust is so fine it bypasses your body's defenses, reaching deep into your lungs. Imagine inhaling microscopic shards of volcanic glass, causing inflammation, scarring, and potentially fatal lung disease. The chemical threat is just as bad. Perchlorates and heavy metals can poison your body. disrupt your thyroid, and cause cancer. Every step outside means exposure, every return inside risks contamination. Chronic exposure could make long-term survival impossible. Keeping astronauts healthy on Mars means keeping the dust out of their bodies. The stakes couldn't be higher. If only keeping Martian dust out was simple. It's microscopic, sharp, and electrostatically charged, clinging to everything. Apollo astronauts learned this on the Moon. Mars will be worse. Brushing it off doesn't work, it just grinds deeper into suits and gear. Airlocks become contamination points, spreading dust into habitats, food, and life support systems. Engineers face a monumental challenge: how to let astronauts in and out without bringing dust inside. If we can't solve this, long-term Mars habitats may be impossible. The uninvited guest, dust, could take over the house. NASA is racing to tame Martian dust. Electrodynamic dust shields use electric fields to repel dust from visors, panels, and suits. Future spacesuits may use non-stick materials or self-cleaning tech, vibrations or gas jets to shed dust. The most radical idea: suit ports. Astronauts enter suits from inside the habitat, leaving the dusty suit outside. Each solution has challenges: power demands, complexity, maintenance. There's no magic bullet, only a layered defense dust repellent suits, active cleaning, and advanced airlocks or suit ports. Even then, contamination can't be eliminated, only managed. The goal: keep dust below levels that threaten crew or equipment. It's a technological arms race against a foe that's been there for billions of years. On Mars, dust is the enemy you can never fully defeat. Suppose we master dust control: self-cleaning suits, flawless suit ports, safe habitats. We protect ourselves, but what about Mars? The places we most want to explore for life are the most vulnerable to contamination. Aggressive cleaning could destroy Martian biosignatures, lax cleaning could introduce Earth microbes. The dilemma: protect ourselves or protect Mars's scientific integrity? Astronauts are walking bags of microbes. Keeping habitats from shedding life is nearly impossible. Dust sits at the center of this conflict. Our fight to survive could erase Mars's history. As we become a two-planet species, we must choose our safety or Mars's pristine story. The dust will remain unchanged. The choice is ours.